Greenhouse gases exist naturally in Earth's atmosphere and take on many forms, including water vapor, carbon dioxide, methane, etc. Greenhouse gases are significant to our Earth because they absorb heat, releasing it out into the atmosphere. They benefit us by helping with photosynthesis and keeping us warm. Without greenhouse gases, the Earth would drop dramatically in temperature. But what is the recurring problem? The problem is that there has been an increase in greenhouse gases like carbon dioxide and methane. Due to human activities like the burning of fossil fuels, deforestation, and other agricultural practices, the Earth has been warming as concentrations of greenhouse gases increase.
This increase in temperature has been followed by the increase of heat on the surface, causing the warming of the troposphere. The troposphere is an important layer that holds water vapor, regulates our temperature, and produces our weather. Greenhouse gases for the longest have been increasing, but due to human activities, there was a sudden spike. The effects of this increase have been divided into two categories: the positive and negative feedback. These feedbacks have developed on events like the fluctuations of water vapor and other indirect effects.
Positive feedbacks are what we are trying to avoid as they amplify the atmosphere's warmth. The positive feedback loop explains what exactly happens. Following the diagram, it delineates the increase of carbon dioxide, creating a warmer atmosphere, making surface water vapor more often, leading up to the increase of water vapor, and because it is a form of greenhouse gas, the atmosphere then tends to warm up. These feedbacks are dangerous because even a modest amount of warming at higher latitudes, like Alaska or Scandinavia, can lead to substantial melting of snow and ice, exposing soil, rocks, and ocean surface, which could greatly increase carbon dioxide to a higher peak.
An example of positive feedback would be the melting of permafrost. Permafrost is a thick layer of soil that has remained frozen for many years, which is common in Arctic lands, and if melted, it will release a powerful amount of methane. This is hazardous, especially in the condition the Earth is now, because methane is a much more threatening greenhouse gas compared to carbon dioxide, which, if released, can cause a frightening increase in temperature, further reinforcing the feedback loop. Hypothetically speaking, if methane is released into the atmosphere, it will become oxidized and become CO2. An increase in methane ultimately results in an increase in carbon dioxide and will stay in the atmosphere for about 300 to 1,000 years.
Negative feedbacks are beneficial because they help reduce and diminish the already damaged environment and assist in maintaining balance. The negative feedback loop explains that after the warming of the surface and the increase of water vapor, some of the greenhouse gases condense to form clouds, and those clouds contribute by trapping heat in the atmosphere and reflecting solar energy, ultimately helping to cool the planet.
An example of negative feedback is the creation of low clouds. These low clouds would have a stronger ability to block sunlight than extensive high-type clouds. If the low clouds become more prevalent in response to the increase of CO2, it will have a cooling effect that can offset some of the initial warmings. Ice sheets melt could also increase cloudiness with more water vapor in the atmosphere. Clouds reflect 1/3 of incoming solar radiation, and there will be less heat absorption on Earth's surface.
So positive feedbacks are expected to outweigh the negative feedbacks. We have to engage in mitigation to completely reduce the greenhouse gases released through human activities, allowing the Earth to regenerate and heal over time.